Cryonics, the hope for life in the future. What is cryonics? Cryonics, or cryopreservation, is an effort to save lives by inducing a corpse to a temperature so cold that it allows for body preservation for decades or centuries until a future medical technology can restore that person to full health. The idea of cryonics was founded by physics teacher Robert Ettinger in 1962 with the publishing of his book, The Prospect of Immortality. Although the reaction to Ettinger's book was initially small and skeptical, few years went by before 73-year-old psychologist Dr. James Bedford became the first person to be cryogenically frozen in 1967. His body is reportedly still in good condition at the Alcor Life Extension Foundation. By the late 1970s, there were about 6 cryonics companies in the United States, but the process of preserving and maintaining each body indefinitely was extremely expensive, causing many of these companies to close by the following decade. Today, only a handful of companies offer full cryosuspension services, including Alcor Life Extension Foundation in Arizona and the Cryonics Institute in Michigan. The process behind cryonics is an intricate one. Because this procedure is extremely delicate and mostly dependent on the survival of brain function, time is of the essence for successful cryopreservation. Within 2 minutes of death, a heart-lung resuscitator must be used. This machine conducts a form of computerized chest compressions that ensures that the body is stabilized and that the brain is kept supplied with blood and oxygen, despite the fact that the heart has stopped beating. During this period, an anticoagulant is injected into the patient to prevent the blood from clotting during transit. After this step, the patient's body is cooled in a body bag filled with ice, ensuring that the head is completely submerged in the ice water throughout the transportation process. Once the patient arrives at a cryonics facility, a process of perfusion begins in which the patient's blood is removed as cryoprotectant agents are introduced to replace the patient's blood and body water. This vitrification solution is used to stop the cells from freezing and prevent ice formations around the organs, which can occur due to the low temperature freezing of the body. The body is then placed in an insulated pouch and moved to a controlled cooling unit where the pouch is opened slightly to allow for consistent cooling. The patient is cooled to liquid nitrogen temperature for approximately 5.5 days at negative 130 degrees Celsius. Once the patient reaches this ideal temperature, he or she is carefully removed from the cooling unit and placed in a cryotank. The patient is inserted head first to ensure that the brain is always at a low temperature and withstands the possibility of a leak by remaining immersed in the freezing liquid. Following these measures, the patient is quickly transferred to the cryostat, a larger metal tank filled with liquid nitrogen to keep the temperature at negative 196 degrees Celsius. 4 to 6 bodies are typically placed in the same cryostat. This becomes the last stop for the patient and is a long-term storage unit where the body will remain until technology allows for revival. The possibility of reanimation for cryogenically frozen individuals rests in the hands of scientific and medical advancement. Those who surrender themselves to this process do so in the name of hope and trust in the technology of the future. Currently, close to 300 individuals in the United States have been cryogenically frozen, and a few thousand prospective candidates are signed up. Although no cryogenically frozen human has been reanimated, scientists are relying on the advancement of certain fields, such as nanotechnology, the manipulation of individual atoms and molecules. Proponents of the movement, including Jerry Lemler from the Alcor Foundation, argue that as long as the material structures of the brain are not severely compromised, its restoration to a fully functional state with memory and personality intact is in principle feasible. The hope for reanimation in the future, then, rests on the success of maintaining the human brain intact so as to enable the possibility of salvaging the information and material that comprises a human. Although the idea of a second chance at life may seem intriguing, cryogenic freezing raises questions of ethics and incredulity from certain groups. Skeptics have doubts that future advances will ever be able to progress efficiently to revive the cryopreserved body. This raises a question of ethics, given that cryogenic facilities charge a minimum of $150,000 or more for whole body cryopreservation and $80,000 for a neuro option, in which only the head is preserved. Additionally, some share concerns on whether the cryopreserved person revived in the future will retain the same amount of personhood and identity as before. Because the body is preserved for such a long time period and the brain is affected to some degree, there is worry that the nature of a person's disposition will be altered. Opposition is also found in religious groups, who find the process sacrilegious. Because the cryonic suspension cannot take place until after legal death, cryonics is often viewed as occultish, and those who perform the procedure are considered witch doctors. A last concern is that cryogenic reanimation could contribute to overpopulation. Cryonics is proof that science and medicine are constantly advancing. However, the suggestion that life after death through future resuscitation is possible has not convinced everyone in the field, and much work rests ahead of scientists and medical professionals to prove the public otherwise.